Okay, I think we're good to go, and you should be able to see my screen at this point. So welcome everyone, especially those who are coming back to us again after seeing your names in the pilot sessions. We really appreciate you having us back with you again. There was such a significant change to our curriculum that we are doing it all again. So all those sessions, we're going to review them. Some of the material will be able to be used again, but quite a bit of it has to be retooled and realigned to the new curriculum documents. So if you are familiar with the pilot series and did that with us and are wanting to use the materials from there, you will have to go and match those now to the new outcomes, because there were, as we said, some very significant changes and moving around of what outcomes went where. So it isn't a perfect match anymore. So to get started, my name is Chris Sarsky. I'm one of the consultants that works out of the CARC Regional Consortia, so Central Alberta, and I have the absolute pleasure to work with a great partner who is going to wow you with his concepts and all of the work he's done behind the scenes to save you work today, and that is Ted, and I'm going to let Ted introduce himself as well.
Good afternoon, everyone. My name is Ted Zeroni, and I'm happy to be joining with you this afternoon. I'm currently in Sherwood Park. I'm working with the Edmonton Regional Learning Consortia. And thank you very much again. I mentioned it earlier, but thank you for taking time out of your very busy day here in mid-end June on a hot day to join us for this session. And we think it'll be worth your while. So welcome, everyone.
Yeah, our countdown has begun, and I do know that it is busy. And I don't know about where all of you are coming from, but I do know that I'm coming to you from Camrose, and outside right now it looks like midnight. It is so black. So I'm not sure what's coming our way. All right, let's get started then. So for anyone who did do the pilot with us before, you'll know that when we do the land acknowledgement, we try to embed some information in there that would be relevant to either the organizing idea that we are talking about, or that it would link to something that we are going to share with you as a resource. In this particular sharing, instead of a video, you have a Venn diagram. And that Venn diagram, depending on your background and what you've had available to you for resources in the past, compares traditional Indigenous Native language or knowledge to the Western science knowledge. How do those compare? And do we look at things in exactly the same way? And for those of you that followed through with Living Systems, we had a video, but you also learned that we don't look at it exactly the same way. There are definitely commonalities in the center of our Venn diagram, but there are definitely differences in how we see the worldview. So for example, in a Western science, we see ourselves as humans being at the top of the pyramid for energy and for as far as the we are the top carnivore in the whole mix. Whereas if I look at that through an Indigenous lens, I am no more important as a person as I would be than a grasshopper or a piece of grass. Everything is seen at the same level. And so it's knowing those differences too, that when we have conversations, it isn't just about reading out what's in a book. We want all of our students to see themselves in the lessons. And so presenting all different aspects and sides of the information is going to be really important, especially in science. So to move on, in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So our setup will be very much the same every time you join us, whatever the organizing idea is. We'll always try and give you some background information, especially about sort of the phases of learning and how those impact our teaching pedagogy and strategies that we might be using. We look at what's the difference between surface information and deep and transfer. So how do those fit into this mix of concepts that we have? We'll talk about how we can unpack some of those understandings, which are really the more important pieces of all of the information you get in a CUSP is the understanding. And then what does it look like when I want to go deep for assessment to know if they know it, and then I want to go even deeper for transfer. So we'll talk a little bit about that. we'll look at resources that might help augment each of those 3 levels. And again, suggested only. They're not saying they're the only way to go and the only things that you should use. And then we'll also talk a little bit about computing science and scientific method. Okay. It is super stormy here, and I'm not sure when my computer is freezing up here. What's going on? Okay. Let's try that again. There we are. So just to start off with, before we launch into the actual grade 2 curriculum, remember that this is a spiral curriculum now. We are now no longer teaching science in a box. It's not just about, I teach these 5 topics in grade 2, and then when they move on to grade 3, they get 5 new topics. Somewhat disjointed in cases. We didn't necessarily have any carryover. So a child could miss a unit, could miss a grade in science and still be very successful in the next grade. We are now in a curriculum in which what we teach in kindergarten impacts grade 1. It carries over those important concepts, and we need to build on those concepts in grade 1 for grade 2 and grade 2 for grade 3 and so on. So in this starting year of science, it will be much like math was. We need to go back and bridge some of those key concepts. You're not going to teach the whole thing, but where possible, I'm going to outline some of the key things that happened previous to your grade so that you're aware of it. And you might want to pre-assess your students to find out what their knowledge is, because they won't have come from a new curriculum landing in your doorstep in September. So from that perspective, what do I need to know? What maybe should I just check to see what they know? Where do I need to back up? And if I do need to back up, you have access to kindergarten and grade 1 to go back and get whatever materials and resources that you need at that time. So coming from grade 1, they've used one of the skills that we talk about, and it's mentioned in your skills and procedures, of a sort. What is a sort? How does a sort work? Generally it can be cards, and that's really what we gave them in kindergarten. We used cards. We used some in grade 1. They were slightly different, but it's a process by which students are tasked with basically just taking those cards and either putting them into piles of their own choosing, because then they're going to explain their thinking to you, and you're going to scaffold them to get them to where you want them to be and what is the concept you're trying to unravel. Or maybe you taught them the concept and now you're asking them to verify that they understood it by doing a card sort and putting it together in the concepts. Kind of your choice. It's a great way to know whether students know what they're doing and what not doing. And so TED has created step-by-step procedures for you. If you have never done a sort before, these links, you will get the slide deck. So once you get the slide deck, you can click on any link and go back into it. You can also go back into grade 1. You can also go back into kindergarten. They talked about what is an object. So in kindergarten, they really work on what is an object? How do we define it? What are some ways that I can describe it? What are properties of objects? And then we use our senses. They learn about their senses, which used to be grade 1, is now kindergarten, to describe those properties. So those were kind of how we unpacked matter in the kindergarten levels. They talk about the difference between an object and a property. And these were the cards that we gave them. Again, if you want to use the cards, and you could use them again in grade 2 for other things, depending on how you want me to demonstrate whether I know that it's a man-made or a synthetic particular material, you could use it for that as well. There's lots of cards there. And when the students do their cards, we start prompting them by just asking questions. Why did you put the things in the order that you did? We didn't tell them what to put in what piles. We just said, put them in piles that make sense to you. And then what made sense? What was it you put together? And some said color, some said food, some said instruments, some were animals, whatever their rule was, it didn't matter, because we didn't teach them anything yet other than just putting them in piles and explaining to us what their thinking was. And then as we start to refine it, as we start to learn about our senses, then I could ask them to resort them and say, what are the 5 senses? And based on the senses, now I can ask you to look at them again. And how would you put them in piles? So if I was looking at eyes, if I was looking at taste, I was looking at touch, what things would go into each one of those senses if that was how we were going to group them together? So again, you're using it as a formative assessment. Again, this is kindergarten. We task them with generating a sort of a word wall of what are some descriptive words that I can use for those properties and in the senses, like how will I describe something? What if I asked you to put your hand in a bag, but you can't see what you're touching? How would you describe it to me? Could you make a best guess of what you think is in the bag? That's a typical kind of activity that we might do, but also gets to whether or not the students really have understood what it is that we're asking them to unpack in senses. So do they know their senses? Do they know what the property of senses are? And do they know words to describe those senses? So that's those properties, sorry. So that gives us sort of an overview of really what's happening as far as the kindergarten student is concerned. How do shapes, how do properties of objects determine maybe design? So if I have some wooden blocks in my room and some of them have rounded edges on it, well, that's going to change what I can and cannot stack, because I can't stack on a rounded shape or an edge as easily as I can if it's on a flat shape. So it's a property again that we talk about. Every one of these is a link that you can click on and there's more information behind it. If we go to grade 1, we start doing that same idea with sorts. We're looking again at objects and properties, but also we tie this very much to math. The way that they unpack your science, we would really or should really be doing it at the same time in mathematics. And you can see how the links over here in science are fitting both with the geometry and measurement unit that we have, as well as number. And then in stats, we can actually get it into that as well. So we should tie these together so that students aren't just thinking that this only happens in science, this only happens in math, so that they see how these are fitting cross. So the concept of properties, we unpacked the fact in grade 1 that they had measurable properties, that I could examine them using tools. Tools could help me to determine what kind of a property it is. Maybe I have to bang on it to find out that it's really hard. And are there ways that I can change? Are there ways that I can change those properties? If I take a balloon, for example, and I blow the balloon up, I still have the same balloon, only it's enlarged in size. So the size might have changed, but the actual tools and manipulative and the mass of that balloon is still the same balloon. It hadn't changed. I didn't add more rubber to it or anything like that. I just blew it up. So it changed its shape, changed its size. So these are the pieces that we unpacked in grade 1. So again, if there are things there that you feel we're going to need to maybe just do a quick review on, you have access to all of the slides and all of the resources that are there. We talk about length, we talk about area, we talk about texture. So we talk about how can I demonstrate some of the differences in length, and it's just comparative language that they need. This isn't a formula of any kind. So longer, shorter, fatter, wider, skinny, that kind of thing. If I take all the yellow cars that I have in the toolbox, anything that's a yellow toy, and line them up, and I have all the orange ones and the red ones, which one is longer? Okay, or which ones are the same? Or go out and pick up some sticks outside, which one is longer, which one is wider? So it's comparative language based on that. It isn't using a ruler per se. We could say, I'm going to measure the length of my book, and I'm going to say it's 5 paper clips long, or it's 10 paper clips long. That really is something that we would do in grade 1. However, this is more of a grade 2 outcome. So you're using non-standard units. So depending on whether they're familiar with that, then you might already have students that would know that kind of thinking, but that's really what you're unpacking in grade 2. In area, again, it's not a formula. It's if I were to put a can of soup on a grid and I were to put a box of tea on the grid, which one covered more area? Which one covers more squares? So that's the terminology that we were unpacking when we get into grade 1. And again, there's more of that in that particular lesson, if that's where you want to go through. Comparing mass and weight, what's the difference between the two? And again, there's some videos there if that would be helpful for you just to show. And then again, just measuring, straight out measuring of what a unit or what a particular value is. You could tie it into your math at the same time. Cuisenaire rods are weighted, so I could take a balance scale. That's a tool, as a balance scale. I'm going to show you how to measure the balance scale, or how to recognize whether they're balanced or not. But I could use that and tie it into math at the same time. I could use a magnifying glass. I could use a weigh scale. So I need to teach them how do you read that. So you can't just assume that they know it. So these are tools, common tools that we might use for measuring, or a paper clip, or how many pencils long is something, or something like that would be the same. So these are, again, just places that you can go. You'll see up here, I put that the videos unpack that, but they definitely also hit the mark for you as grade 2. And then one of the last things that we did is when we talk about physical change, assessment, you start as soon as you bring them up. We want to do a bit of an assessment to see whether or not they really do understand how properties might change. So I can change the length of something, but it's still the same matter that I had. So there is length, area, shape, texture, and weight. And I would watch this one just looking as a quick review for physical changes. And then we included in here down at the bottom is a number of cards. They can just print off the cards, and they would put the cards based on their number. They have a number on the bottom. Where do they belong? You know, is this an example of a change in length? Is this an example of a change in area? And in some cases, they fit more than one. And that's where the richness and the depth of thinking comes in, is they do fit in more than one area. So that would be a good one to maybe review a little bit with your grade 2 students before you get into your outcomes for grade 2. So we're going to talk now a little bit. We're going to swing over to 10, and we're going to talk a little bit about what are the concepts that live in matter for grade 2, and then we'll come back and look at some examples.
As Chris mentioned, we're going to just flip back to that first video just once in a while, not for all these sessions, but just for the second one, in case some people missed that very first recorded session. We are basing our presentation and how we're unpacking the curriculum and presenting it to you based on the phases of learning, the Hattie-Fisher-Fry process of surface, deep, and transfer. And just as a quick reminder, the surface learning is where we teach the basic things to the students, the basic skill we're going to need to carry on through that cusp line. What are the concepts, the key concepts in that cusp line? How do we get kids to learn them deeply and understand them? And then we move to the understanding and using the skills and processes to help us deepen that understanding and eventually transfer it. So we'll go to the next slide and we'll show you how we're going to plan to do that. But just a quick review again, that the skills that we teach at the surface ladder are those doing words. They're the things that kids do to demonstrate their understanding or their knowledge. So it's a specific learn. It could be a skill such as sorting is a skill that kids can do, comparing, contrasting, or sometimes it's a procedure. And by grade 2 in the scientific message we'll see later, the process of scientific investigation is a procedure, and you have a series of steps to follow an investigation. And some of those steps are specific skills within themselves. But it's those little basic things that we want to introduce students to at the surface level. Next slide demonstrates some of those key doing words. Go to that next slide, Chris, thank you. What we've got here on the left is a list of all the doing words, the skill words that show up. No, you were on the right slide, Chris.
Sorry, it's delayed and it's just changing it on its own here. Sorry.
Okay. I
I'll
changed
get
the order
back to it.
of them, and I thought you were looking for the right order.
No, it's just for some reason I'm just frozen on here and it won't let me go back.
Oh boy.
Come on, let's go here.
How about the arrow on your computer?
That's what I'm trying now. Wow.
Escape and restart and click on. Well, we move forward.
Yep, there we go. Let's try it again.
There we go. Okay. Yeah, it would be helpful to have that skills slide on there.
I'm just going to stop our recording just
Yeah.
for a second. Come on.
How about if you escape from the slide presentation itself and then click on the slide to begin the presentation at that slide. So anyway, on the left-hand side, you'll see a lot of those doing words. Some of them are the skills themselves or procedures. And the way we derived that list was by looking at all of the skills and procedure statements in the entire curriculum from K to 3. And decide and determine the frequency of how often they appear, and if they didn't appear much, whether they were what would be considered a significant one that students should know. And we came up with this list, which is a lot smaller than the original list in the pilot program. I think there would have been over 100 on the pilot. So that's a nice reduction in the skills. One thing to notice is that when you take a look at the dark statement, that's where the skill itself, the ask the questions or the classifier or sort, record data, it's specifically used in the skills and procedures statement at that grade level, somewhere in one of the organizing ideas. When if it's a lighter shade, it doesn't show up as a specific doing part in the skills and procedure. But if you think about it, or when we look closely, it's interpreted in it that it should be included at that grade. So ask questions, for example, is only mentioned as a skill and procedure, or part of that skills and procedures in kindergarten, not anywhere else in grade 1, 2, or 3. However, when we look down to investigation and the process of investigating, the first step in the process is to ask a question. And so it's assumed that students will be practicing that skill of asking questions. What's a good question? How do you maneuver a question? How do you get deep with questions? Same thing with predict. You can see that it's introduced across the way, or excuse me, observe. You can see kindergarten and grade 1 have it directly included, but it's not included in grade 2 or 3. Again, it's embedded in that investigation piece. Same with conclude. So by looking at this list, you can see that there's really a lot of similarities for the whole K to 3 curriculum. And I guess what we're getting at then is when you're teaching these things, we want to make sure they're good at that individually at the surface level. And another thing to keep in mind is that it may seem daunting to say, how am I going to teach all these things in science? Well, when you really look at them carefully, we do these specific things in a variety of subjects. We can ask questions and help students learn about asking questions in literature when we're doing literature. We can make conclusions with art after they do something in art. They can make some kind of conclusion based on what they see. They can make observations in a variety of settings. Well, we get students to predict in a variety of settings. So these are things that may appear in science, but at the end of the day, the doing verbs are what skills or what students do to demonstrate their understanding or their knowledge. And these are powerful ones, and that's why they're used quite often in the skills and procedure statement. So that's one thing then to keep in mind is that we're talking about at the surface level, working on the skill. Look at the skill in that skills and procedure statement and ask, do my kids know how to, for example, compare and contrast? If you know you're going to use it in that cusp line, then you'll want to do some work at the front end on the surface level, helping students compare and contrast. When it comes to concepts, and we've moved a little bit quick there again, that's the one I want right there.
That's the one.
But not only do we teach skills at the beginning or that surface level, we teach the individual concepts. And just a reminder, the concept are those organizing ideas of 1 or 2 words with a definition and have many examples. Fruit is an example of a concept, and we can classify or categorize all those items there as fruit because they share those attributes that make them so. We wouldn't include a carrot in that because it doesn't have the attributes that a fruit would have. So we take those concepts, and again, you'll notice we go from a one-dimensional kind of thing, a flat word concept, to a cube. And the reason for that is when we're talking about a concept, we're going beyond just the definition. We want it so that students can give examples of that concept, or non-examples of that concept, or given a context and say, can you identify the fruit in this picture? Which ones are the fruit, or whatever the concept is you're looking at. So that's what we got at 3-dimensional, going from the definition to actually being able to find examples and non-examples in a variety of different contexts. So if we were to take that surface, deep, and transfer mode and take a look at how it relates to the curriculum, we'll take a look. I'm jumping out of myself. Still stuck on concepts. We'll take that last statement back. All the concepts in each organizing idea can be organized in a meaningful way. In this particular case, we took all the sort of the key ideas and included concepts from matter and organized them in a way that can provide a picture of what is in this unit. You can use it for yourself or maybe take chunks out of it and have students work with it. But they're easy to read, and you'll have one for each organizing idea. A way to read these is to begin with the word that looks like the starting point, in this case, materials. And there are some words along the line that can help you flow through it. For example, materials, if we go to the right, can be natural or processed to make objects. And objects going upward have a purpose, which influences choice based on the suitability of that material. Materials, and going down, have properties. Some of them are testable, then that's the focus of one of the focuses of this grade 2 curriculum when it comes to matter. And some of them are measurable, and the measurable properties were examined more in grade 1, but they're referenced again in grade 2. So by looking at that, this gives a really a big picture of really what we're going to be looking at, helping students understand in this organizing idea at grade 2. So the way Chris and I are going to present this, and I jumped the gun again. I shouldn't have moved those slides.
You got used to the other mode.
I know. Working on those concepts individually is important, not only in terms of the understanding, but just individually, it's important as well. Because you can see when we take a look at the matter through the grades, K, 1, 2, 3, 4, and so on, you can see, and you can't maybe make out the words because of the small print, but I highlighted them in orange, that the concept of property keeps on working. It's introduced at kindergarten, grade 1, grade 2, and again comes up at grade 3. And properties is a really important concept because it's not just the description. And it's really tough for kids to distinguish between a property and a description. A property would be something, if there was an apple there, what is one of the properties? I think the first thing people would say, oh, it's red. Well, no, that's the describing word. The property is that it has a color. So at kindergarten, the idea of properties is developed, but we're talking about observable properties. In grade 1, we're talking about measurable properties. Now in grade 2, it's testable properties. What property of an object can we test? And we can test, for example, its absorption. We can test its reflective capabilities. We can test its transparency and its malleability. That's why it's kind of important to look back, as Chris has done with the background, and see that these things live on, and we keep on developing those ideas with the students as the curriculum moves on. Now we can go to the next slide. So the way Chris and I are going to unpack this, the rest of this grade 2, is to go through each of the understandings, because that's really is the key part to each of the organizing ideas in science, is that understanding. There's a multitude of knowledge pieces, but there's only between 1 and 5 understandings with each organizing idea. So, and that's the key part to begin with. So we're going to take you through how you may look at a cusp line and work through the surface level of that cusp line, and then go through the deep. And then at the end, we'll take a look at some transfer and assessment parts. So we're going to take a look at one of the cusp lines right here. There we go. Finally, I'm on that slide. And if we take a look just at the beginning or the middle piece, I've combined the 2 first cusps, which are materials can be combined in ways that to make objects, and the materials have unique properties. This is where the concepts come in handy. Take a look at those understandings, and they've got some key concepts there. They're highlighted: materials, objects, and properties. When I go to the knowledge piece, the part I see there, they are. Materials is in the first cusp line, but we see that properties that are tested, there's the testable properties, the examples of testable properties. And we also know that properties are measurable as well. So what we do then in the surface level, we say what our students, before I go through this cusp line and work to the understanding, students need to know what material is, what a testable property is, what properties are in general if they haven't done that. What's the difference between a measurable property and a testable property, and an observable property is something that we determine with our sentence. And what is an object anyways? And once those singular concepts are understood, we assess. If the kids have it, great. If they don't, we do a little bit of teaching at that surface level, which will help us move to that understanding piece. Then we can start combining them once they understand them. Kids won't be able to make a true understanding if they don't understand what those individual pieces are. So that surface level, we've got the concepts, but we also bring in the other thing. We know we're going to ask students to go to the next slide, Chris. We're going to ask students to test and to measure in this cusp line. At the surface level, we want to give them some some things to practice. What is a test? Let's practice doing a test together. So kids can at that surface level know what it means to test something. So when it comes to demonstrating their knowledge and ability to do that later on, they are really good at testing. Same with measuring. Measure a lot of things, and Chris gave a lot of really good examples of how we can measure at this grade level using non-standard measures. Then we do that at that beginning. When we feel they're comfortable with that, then we move into the understanding. And how can we develop that understanding and teach to that? Because that's really what the kids to what's where our target is, help kids gain those understandings. So Chris is going to take you to a whole lot of different surface level activities that will help develop these concepts and these skills for you.
And just to follow up on this slide, of all the things really that you really need to kind of sink your teeth into with the students coming into your grade are those two terms of object properties in particular. Properties shows up in kindergarten, but it shows up again in grade 5. It's a one of those concepts that lives through your curriculum. So because the students are going to arrive at your doorstep not having done that previous work, that is something you do have to go back and really kind of solidify in their mind. Otherwise, when you send them to grade 3 and they're starting to unpack the properties and changes of states of matter and all this, that word will mean very little to them. So really take the time to go back and grab that information on properties. So when we talk about grade 2, as Ted already mentioned, we're talking about sort of matter, we're talking about materials. So I can go back to that one, I guess. Talking about materials and what are the properties of them that we can test. So again, that word properties comes up. And if I don't understand that, then this is all for naught. This just becomes memorization of these are the terms you want me to learn, but that doesn't mean I connected them to what you want me to the materials that I'm going to see in front of me. So we're looking at how do we make objects? How do we choose the materials that we make objects out of? And then how do we test some of those properties of those objects? So there's even a video in here that will ask them, you know, do you want to make a metal shirt? Some kids might say, yeah, that'd be really cool. But the reality is it's not really a practical use for us on a day-by-day basis. So we want to tie some of these pieces together so that they're seeing the connections between them, not as just discrete topics. So one of the things that I would suggest maybe starting with, and again, for those who are with us for the first time, I'm not a stand up and deliver kind of person. These are just suggestions. That's all it is. I'm not saying that's the way to do it, but I'm not. I like to either expose children to something and then start asking them questions to start honing them into the concept I want them to learn. Or in this case, I might watch the video where it talks about the different kinds of materials that we can make objects out of. And why, where would they come from? Because later you want to talk about natural and process. Those are going to come into the mix in their learning at some point. So this would be one to start with, and then we unpack it. And the nice part of it is it also suggests in here that you might even want to pause it every now and then and just ask them for other examples, just to check that in fact they're on track with you and that they're doing what they should be. So in the short, oops, sorry, I don't know what's going on here today. This is just not the way it usually works. So some of the properties that we really want to talk about, material properties, and that we want them to be able to use as a descriptor is it flexible? Can it bend? Can it break? Is it slippery? Is it soft? Is it shiny? Is it bouncy? Like all of those types of words. Because once I've learned those words, now I can test to see, is an object got more than one of those properties? Do they have a different way that I can recognize them? So I can hold up a piece of wood and I can say that it doesn't necessarily bend if it's a big log. I can't bend it. I can't see through it. It's not transparent. So what is it, right? It's hard, it's heavy, it's not malleable in any way. I can't twist it. So those are the ways that we want students to be able to do those testing. But for me to do the testing, I need to understand the terminology that's going to go with it. So there's no rush to race through this terminology, but also we can also start a word wall up on the wall for them to start giving us words that they can come up with, just everyday lay language. And then we can put the scientific word behind it, right? What does malleable mean? What does transparent mean? They say, I can't see through it, right? Is it opaque, right? So we give them the language, but let them generate it first to start with. So bending, folding, pulling, tearing, those are all things that they did do a little bit of already in grade 1, but on the same token, we really want to unpack this now when I do the testing. These are some ways that I might look at it. Can I pull it and stretch it, right? Is that possible? So these are just surface level. It might seem like you're doing a lot, but really I have to learn all this stuff first. This is just the foundation and ground level of me understanding about what the properties of that material are. And so once I get this all learned, then you can ask me to make comparisons or to go with multiple properties in certain objects. Did you want to go into this one, Ted? Oh, you're muted. Sorry.
I have lots of noise in the background here with lawnmowers and things, so I'm muting myself.
Can't hear it.
No, you don't have to go through that, but what it's a link to is just a template of how you can quickly go to. It's nothing much to you could take a quick look at it. So as Chris was saying, when you're introducing or practicing testing at the surface level, we want to practice that, right? Want kids an opportunity to go through guided practice. So if it doesn't open up, that's okay.
Yeah,
but it's just a chart or a table that can take a look at the 4 properties that are in the curriculum, but Chris had a lot more properties on one of those diagrams. On the type of test, it could be the bending, we keep doing it, but work together what it would be, and then what are the observations with material A, material B, C, and I guess some description words. If it's light passes through it, a lot of light passes through it, or some, or not at all, some descriptive words, just to practice that thing of testing. Now, it could be, if you could test other things, it doesn't have to be materials. If you're doing it at a very introductory level as well, you could choose anything that you can test, but you could use a chart like that to help organize the thought for the kids and put it on a whiteboard or something so they can see how a test might occur.
And they do a very similar one in grade 1 when they're doing one with just seeing whether something can be twisted or stretched or whatever. So again, if you think they have no background in that, then you might want to back up one. And then they'll also be familiar with how to do this chart for a test as well.
So that may think you might want to do at the surface level, right?
Absolutely. I don't know, Ted, what's going on here today? It wasn't that earlier, but anyway, let's go to deep.
Here we go. Again, when that deep level is, you can see from the diagram again, I've taken those individual concepts and I put them together in some kind of an understanding. In this particular case, materials have unique properties. And so that's the relationship. That's the understanding we want the students to walk away with. And is it true that materials have unique properties? Well, let's test them to see what are some of the unique properties that the materials have. And then they come to the conclusion that they do or they don't have unique properties. And they can express, I did this experiment, I did this test. Here's why I think materials have unique properties. And you give them a sort of objects to work with at the deep level. You'll see that you can do that several times with different objects to deepen that understanding. Maybe go for a walk and use different objects or something like that, and keep on changing the context to deepen that understanding. Chris, again, has some more activities now are going to help unpack of how, give some examples of how we can work at the deep level or the understanding level.
Well, we can hope that that's going to go there. So again, as Ted just said, I have a link in here. Any one of these things on the slides, all of these will be active links for you. So we don't have time in the hour that we're together to go through them all. But in this one, it will set up a chart for them. And again, it's very similar to what we just looked at, but now I've got some object. How would I test? How do I test for this? How do I test for this? How do I make sure that I can see through it? So I might have a flashlight, right? And what do I see on the other side? Is it clear? Is it not clear? And then I also included in here, because I think it's important for kids to realize that it isn't always just about whether or not we can do something ourselves, but there are people who have jobs called material scientists whose job it is to test materials. So when we think about new cars and new kinds of metals and new kinds of plastics and whatever, like where did that come from? Who's been doing the work behind the scenes? And that's their role. So again, you can click that on and get a little bit of info for the students just to show them what they do behind the scenes. I've also included, and you'll find them up here in the top right-hand corner, these are a number of different short lessons that you can do to unpack some of the things that we're talking about. So how do I classify objects based on properties? That would be a review. So that would be a good start. And then how do I test the materials that I've learned for the different properties? So each one of those lessons, you can just click on this link at the top and it will come down for you from there. Wherever possible, we try to find you freeware that you are able to access. We don't worry about copyright in any case, but also that it works for our curriculum. That's kind of the prime mover. And then again, just even going along that same vein of we have material scientists, the question is, so I make something, like who really cares? Like, what does it matter what I make it out of? So then the activity that I have there is, can you make a cardboard chair? Would it be real to make a cardboard chair? Well, I guess it depends on the kind of cardboard that I have. But in the real world, is that going to be the way that we would want our furniture to be? So again, it's rationalizing the correct material for the purpose, which is one of the things we'll talk about shortly, of what the particular object is going to get used for. Okay, today would be nice. Wow. I have no idea why this is not working. Oh, there we go. Now we worked. Oh my goodness gracious. We're just going backwards here, people. And it's just jumping around on its own. Okay, so let's talk a little bit about, as we talked about, sort of just surface level kinds of activities. Remember what Ted said, surface is just teach me the facts. Don't expect me to know a lot. Don't expect me to do a ton of deep integration of them. I just need to know those basic pieces. And then when I start to pull the pieces together, the concepts, and I can start talking a little bit more about the deeper ones. So when I talk about the materials and the properties of those materials, I'm looking at the types of materials. I want to see what the students are going to say. You know, there's tons of materials in the world, but would I use them all? Would I use the metal to make my shirt? Likely not. Would I use wood to make my shirt? Likely not, right? So again, it's the students understanding that certain materials have certain purposes and we choose them accordingly. As they get into the next grades, they're going to learn about everything that's not natural. In other words, when it's a man-made kind of material, means I took something from the real world and I added something to it. Maybe I added a chemical to it, or maybe I combined two things and I created a new material. So there's where we're linking to. So this is where the understanding here of knowing natural from man-made. And just an FYI, man-made could be called synthetic. It could be called unnatural. It can be called, there's a third one, but you'll see it in the video. So that just forewarn students that these all mean the same thing. And I would just ask them, what do you think synthetic meant? What do you think that unnatural meant? So that we understand that they learn that there's different terminology. So there is a video piece in here which looks at a city, and it looks at building cities from the perspective of what's natural versus unnatural. And they should see natural things everywhere that they go, but they should also see the unnatural or man-made things everywhere that they go. So when you take a walk around outside in the schoolyard, what's the natural part? What's the unnatural or man-made or synthetic? Are monkey bars natural, right? It's just having that conversation with them so that they're more aware of just their immediate surroundings. Okay, today. Wow.
Do you want me to try to share? Oh, there we go.
Oh, there we go. Okay, so slow as it is. Again, another slide for you. And then down here, these links that you'll find, and this is just a walk around the house, walk around the school, walk around your classroom. What's man-made, what's natural? There's lots of things in your classrooms that'll fit into both. But salt, a lot of them use salt every day, but what do they know about salt? So these are just quick little info clips about what is salt? Where do we get it from? What are seashells? Why are they important? Where do they come from? How do they get made? What is glass? Is glass a natural or is it a synthetic? Kids would be very surprised to find out where it falls. And I think a lot of kids don't realize what glass is made of. So again, it just gives them a little bit of a background to realize that sometimes we think something fits in this category when in fact it fits over in this category.
We've kind of jumped ahead a little. I think we missed a slide, but that's so good because the slide will demonstrate this a similar thing again. So basically, again, what this is a review of, or a graphic of saying here's how we can proceed through the surface, deep, and learning. And we've got another cusp line for you there. If we were to take a look at those about purpose of objects and suitability of objects for a product, we take a look on the left at the bottom that purpose, material, product, and suitability are the important concepts to understand, to develop those understandings. Purpose is new because product might be new. It's a word that's used in the understanding, but product is an object basically that is made from materials. Object is taken in grade 1. Materials, I should add, maybe is the first time students are introduced to that word materials. In kindergarten, grade 1, and grade 1, the word object is used all the time when we're talking about the properties. And now we've introduced materials, which is what objects are made from. And so that's why we introduced those now. So we got to maybe focus on purpose a little bit, suitability, some new skills that we're going to use in this cusp line. So I want to make sure that students know how to compare and contrast and those other skills that are there as well. And then so if you go back to that graphic.
Yep, trying to get back there.
So instead of showing you a repetition of that slide, so we're going to do is move from some surface level activities to talk about the concepts and the skills to getting into some deep learning activities. And then all that has to happen is to get into the transfer is perhaps change the verb that you get kids to do things with. And of course, change the context, use different objects, use different environments and so on for kids to practice their understandings or to demonstrate their understandings with.
And compare is such a big word, right? It's a big word. It's one that requires me to know a lot. So absolutely, we want students to understand that because that shows up not only in science, but shows up in math, it shows up in social studies. So again, that's a big one that Ted's got highlighted. Okay. So again, we're going to look at the purpose of them, and that was the word that was kind of the magical word that shows up there. It shows up in a lot of places. In this particular grade, you'll see that word come up over and over and over again. But again, the purpose of why am I choosing this material? Why am I choosing that property? So what is the use of the object that I want to create or the material that I'm going to be using it for? What's its purpose should also help me to define and look for certain properties when I'm selecting things. So the suitability of it. Come on. Oh my goodness. You know what, Ted? I wonder if you should just start sharing here. Oh, and wants to go backwards just fine. Okay, there we go. So do you want to go through a concept attainment to talk to them?
Yeah, I'll maybe, yeah, that's where, yeah, so I could just show them a concept attainment. When you go through the grade, if you go back to the grade 1 or kindergarten and grade 1 folder in the ARPDC folder, you'll see lots of links to concept attainment activities. And maybe I'll take you through one to get an idea of what it is. Many of you may be familiar with it, but I'd just like to maybe review what that means. So if you're not too sure students understand what the word purpose is, then you could take them through an activity like this, because as Chris said, it shows up quite a bit in this organizing idea. And purpose is one of those things that really come into play when we're talking about producing an object of materials. Well, it's really going to depend on the whole thing of purpose. So when you do work with one of these and open them up, you know what, Chris, it may be a difficult thing to do with your slow progress of your computer. Let's not worry about it.
I have no idea, you guys, why we're doing this.
Just know that they're there. Those links will be there. And what all it is just an example. I can walk you through it with this particular activity. Students are given an image and I point to an object in that image. And there are two statements there. One's an example of a statement that talks about purpose and one isn't. So I've got a hockey picture. One arrow points to a stick. And I said the stick is used to shoot or pass the puck. And the non-example is the stick is has tape at the end, for example. You could just go through the slides that way, Chris, instead of displaying them as a slide show. So the question becomes, and there'll be instructions at the front end of this. What is the yes? Why is it a yes? And then you go through several slides. You go to the next 3 slides, and they keep on adding things to that yes. And then the focus is to ask the students, what do all the yes things have in common? The hockey stick is used to shoot. The shield's there to protect the viewers. The skate helps the players move versus those other descriptors. The skate is black. The shield goes around the rink. The hockey stick has tape at the end. And have them think, well, what does all the similarities have in common? And which one of those 3 statements would be a yes? And grade 2, and this may be too long. Things may have to be changed for grade 2 a little bit with the wording. But just an example of how that happens. So we've identified that one statement. We decide that the puck is shot and passed with the stick and glides on the ice. It was pointing to the ice. So the ice is used for skating on and passing the puck. If we go on to the next slide, then say, well, what is it? Its purpose is a reason why an object is made or produced. So a stick is made for a certain purpose. The ice is made for a certain purpose. The skate is made for a certain purpose, and so on. And then it goes on to practice identifying or making statements. So you can go to the last slide. I've got a picture of a campsite, and it points to certain objects. What's the purpose of that item there, that object? It's an umbrella. What's its purpose? And the rest of the slides will just take the students through pointing through objects and what's that purpose, just to give them that sense of what is the purpose. Once they understand that is, and well, Chris will take you, she's giving you some examples of how then that's going to relate to the suitability and why we choose certain materials with certain properties, depending on the purpose, what we want to use it for. I'm not going to go through that. Similarity and difference, another concept attainment, because if we are going to compare and contrast, students will want to know what the difference between a similarity and difference is. They may already know at grade 2 level, but this would be concept attainment activity to really make sure whether they do or not, to help you with that if you think your students need that. Again, surface level work, right? We're just identifying what these concepts are.
So one of the things you could do is a Venn diagram. So that's it gets into the deeper part, right? Remember I said we have to know something before I can do some comparing. So this could be a potential deep question in which I'm asked them to take some of the properties that we've tested for already, like transparent and rigid, and I might give them a whole bunch of different objects and say, where do you think they belong? Do they belong on the transparent one? Do they belong on the rigid one? Or do they belong in the middle? And so just to help things out, I won't go into it right now, but if you click this on, I've given you 8 cards, pictures of items, just random items that you could simply print off, cut out, give to the students. And for people who haven't been with me before, the best Venn diagrams are hula hoops and get the kids out of their desks and on the floor. So you could simply just take the hula hoops, lay them down, put the transparent rigid headers inside, give me the cards, and away I go. And if you're a center type of person, you like to have kids working at different centers, nothing would stop me from having a variety of hula hoops laying on the ground. So different locations in the room, each of them looking at something different that I've already done some testing for. So again, you could just create your own little slide deck or give them objects in a bag, and here's your bag, now go and put them in and let's see what you found. And then I can walk around and ask students to explain what they're doing. So it's a great way to get them out, but it's a super assessment. It really gets to whether or not they can explain, can they use some of the scientific terminology that we've just taught them? Are they able to discuss it with us? And that's what Ted's going to talk about here right away. So that's a great tool for assessment and learning.
And again, discussion is really an important skill that shows up in every skills and procedures statement and almost every organizing I did at every grade, all the way up to grade 6, especially in the primary grades where kids can't communicate well with writing to demonstrate their understanding or their knowledge. And so it's often, you'll see in the skills procedure, to discuss something. And at the surface level, something maybe that we haven't done that might be, some of you have, I'm not too sure, but it's something I know I haven't done when I was teaching, and I wish I would have, was talk about what a discussion is, produce a checklist, and actually at points along the way, give students feedback on how they're discussing. The checklist that, don't have to go to that, Chris, but the checklist that's developed there is based on the competencies that you can access on the New Learn Alberta site. They're the Division 1 competencies, and I pulled things out of collaboration and communication, I think, to create a bit of a checklist to say, okay, here's what we're looking for as a class, and talk to the students about what it is. And then not only can you give them some feedback and check in on a couple students every so often to see how they're doing, give them some feedback, but using different formats for discussion instead of just a general talk. You can organize it as a gallery walk and all those other types of discussion formats to get kids to discussing, and then us as the teachers, the educators, get in and listen to the discussions that they're having, not only to give students feedback on their discussion and what they're doing, if they're being distracting or things like that, but to also get feedback on, they're going to be discussing their understanding, their knowledge of stuff, and their rationalization of why they're doing something. And that gives us lots of assessment information as educators. So you could, might be a good idea to, if you've never talked about what a discussion is, and take a look at the checklist before, that'd be something you could do at a surface level before you start beginning a cusp line where you're going to get them to discuss thing at the end to show their understanding.
And then again, when we talk about purposes, here's my question about, would you like a metal shirt, right? When we still get to that purpose and we're still trying to get a little bit deeper, why don't we take something that's super familiar to them? The story of the 3 little pigs. Just read that and then ask them, how does that fit into materials and our discussion that we've had about purpose, right? What happens to them when they build their 3 different houses? What was the purpose of the house to begin with? And when I talk about the first pig being the laziest one and wanted to have the simplest way of doing it, did he pick the materials that fit the actions that he had? Yes. Was it the best purposed material for the intent of it? No. So again, just taking a fun story that they've heard before. You could also take the opposite of that. You could take the true story as told by the wolf and read that story, and how did he come about blowing the houses down? What happened? But again, talking about the substance that he was trying to blow down, the structures. So just a way that we can do a little bit of fun activities with them, but still tie into what it is that we were working on. I've also included for you a number of resources here when we talk about natural products and used for purposes, and specifically in your knowledge component, and they refer to how do Indigenous and First Nations use natural products or products with purpose? How did they decide what the purpose was? So in here, I've given you a suggestion. This comes from a series of books, which I will show you in just a second. How to create a birch bark canoe. So those were very popular, very common to be made. I've given you some information about birch bark biting, which is still happening now and still being used. So again, just giving you some info that you can add into the mix about when we select materials for purpose. How did that happen? And this time you can link it directly to the Indigenous culture. If I want to get changed here, come on. Oops. When we look at, I think I skipped another one. So we have some for the Inuit as well. The booklet here has a number of different resources. Comes from the Grandfather Grandmother series that you can purchase. They're sold in Edmonton through Native Reflections. You can buy the entire series there. The buffalo would be another perfect example of, there is nothing, when there's a buffalo that is hunted and used, nothing on the buffalo is wasted. There is not one ounce, not one hair, not one hoof, nothing that is not used. And so in the diagram, and you can go in and collect this and click this on as well, it shows you all of the different uses for the different parts. So again, for purpose, what is the purpose of a natural use? In this case, it was also for survival. We know that there are 4 sacred plants that Indigenous cultures will use as well, and the meanings behind those. And those are, again, the natural plant is used for a specific purpose. Why do we use sweetgrass? Why do we use tobacco? There's a link in here called Land and Resources, which is a summary of how First Nations would have been using living off of the land as their primary focus. And that's one of your outcomes, or one of your knowledge components that you have in 2 of your cusps that show up. And then again, when we talk about natural products, we're not just talking about buffaloes, we talk about seals, we talk about snow, we talk about the natural wood that we would use within the different areas. Willow branches used for medicine, as well as they are sacred as well. And you don't just go cut a willow branch off. There's a process that goes along with that.
So again, when we're getting to a deep activity, again, it's taking those, when you're at the deep level, it's taking those skills and procedures statements, and you can use them for the deep level. In this particular one, there is the skills and procedures statement that says, select a material and use it to create an item for a specific purpose, and explain the relationship between the purpose of the item and the suitability of the material that was used. Then now they're creating their own objects. Again, a way for them to demonstrate their understanding for you, or to deepen their understanding of the relationship between material, purpose, and why it's suitable. And finally, the last cusp we're going to look at is again, looking more at the natural process ones. Again, we've kind of worked through some of these slides. With this learning outcome, a lot of the understandings and cusps are kind of intertwined and interrelated. So that's why it seems like we're being repetitive, but not really. There's in this particular one, we may want to investigate to deepen things. For example, the green highlighted part says, and this is again where we're getting to either the deep or the transfer, is to identify natural process materials that could be used for a specific purpose. That would not be a deep level activity, because you're really getting them to, you're really assessing their understanding of just the individual concepts themselves, distinguishing between natural and processed materials. But if you turn that into investigation and you ask a question, okay, what are the origins of these materials? Let's make a prediction and create a conclusion. And their conclusion could be that natural and processed materials create objects for a specific purpose. So that's why I put investigate in there, to turn that into more of a deeper transfer level activity, other than just identifying them. And we can go on through some more examples. I think you have some more, Chris.
Yep. Assuming it lets me. What is going on?
I'm gonna let you.
Come on, let's go. Yeah, of course, a whole bunch at a time here. So when we go into looking at even just what was in your knowledge component there, they're talking again about what are natural products. We take this one step further, just again to give you some examples of some of the ones that were listed in your knowledge section. We could look at a Red River cart, and some students don't even know what that is. That will be news to them. So to understand what a Red River cart is, and the fact that a Red River cart was made entirely of wood and has no metal at all on it. Everything that was put together, anything that holds that cart together is done with wood. And so that's why I've just sort of given you kind of a look here on the side, that they don't think that there's a metal bolt that hangs some of this together. There's no metal on these at all. So just giving them some fact information. I've given you a link there that if you want some more information about what did they hold, what did they use them for, versus, you know, if we look at today's kind of world, and we skip that one, we talk about a truck, right? How different is that? So same thing, I'm still carrying items. I'm still going to carry What's the difference in capacity? How are they different comparative? So it's not just learning about this is the material. Let's also put it in a practical context. And do we want to walk around with just wooden carts today? No, because we have engines. We have the ability to go faster. We have the ability to carry more if we needed to. So you could even extend that to an airplane, right? How do you make the fuselage of an airplane? How's that a conversation that could be had? Which is a good grade 3 conversation as well. I've also given you a list of, because we don't spend a lot of time with our Inuit references as well, and we should, because we have a lot of Inuit students in the province that are attending our schools. And so we really need to make sure that they see themselves in some of this as well. We don't have the language as easy in for the Inuit culture come to us as we will, let's say, for example, the Cree language might, because you may have many of you that are teaching that in your schools already. Not to say that you're not doing other ones as well. But in here, what I've given you is from Nunavut. This is an institute, and the institute itself will talk you, when you click on the link, it'll tell you a little bit about what this institute does for Inuit recognition and education, more education of us than for them. It also talks about collections. So in the collections, what are the things that they focus on? What are the things that are most valuable as far as their immediate environment is concerned, their past history of use of tools for the right purpose? And more specifically, when you click on the land one allows you to kind of go in and grab a few bits of information. Down the left, I know this is hard to see, it's because it's in yellow, but down on the left-hand side, you have a lot of options there from the different cultures. But if you go into just the land, and for example, you were to go into, let me just grab one here. I'll just click one of these on. It's called All That Is Precious to Us. It will talk about their environment. What do they look for in the land that sustains them in a natural process? What do they make as materials from the land? And what do they use them for? So it gets into the purpose part again. There's a number of links towards the bottom there that each have their own page like this. So I would encourage you to have a look at that, because there's a lot of really interesting information to make the same connections that we just did with the other slides that we looked at for First Nations as well. Okay, so for transfer and assessment. Oh, you're muted, Ted.
When we're talking about assessment, that's where we were talking about that last piece, the transfer. And really the difference between working at that deep level and the understandings versus the transfer level with the understandings is simply the context and the degree of independence we're having the kids work at it. So we can use a lot of these activities that Chris has already shared. It doesn't have to be a paper pencil test, especially with doing all those formative evaluations. We give students an assessment, and we're always observing, we're always having conversations with students. Sometimes they're making products. And we use that triangulation that we've always used to really make an assessment. And we know they've got it when we give them a very unique, a very different context or different context that they've never seen before, such as the Red River cart versus the truck, right? And have them discuss about uses and properties, natural and properties and man-made properties and the purpose and so on. And having those discussions with that kind of activity will give you a lot of assessment material. And it's always have to remember that the other thing to consider is that whenever we use those skills and procedure statements or give them one of those things, we're really asking them to do something to demonstrate their knowledge and understanding. And we don't necessarily have to use these skills and procedures verbs that are there. We could use other ones. A relate is used once in a while. We could also use relating the ideas together. So what's the connection between assessment? What's the relationship between material and the purpose? And see if they can utter that relationship. That's getting a bit deeper, but with practice, students can start stating those relationships to you, and you get a sense that they now have that understanding as well. Chris, you've got some more.
Yep, and what Ted just said about the transfer, that is just making it more independent. So when I'm talking about you're seeing on the screen right now, just having is typically kind of a worksheet just to check. This would be more formative, more as we're going along. I want to just check to see whether they're doing something, but it's that level of independence and the fact that I'm giving you a whole new environment or new object for you to unpack that will take me to that deeper level thinking. So again, for these ones here, they come from K5. The link is at the top and you can download those at any time. And K5 is one that I would bookmark when you get to it. If you've never used that site before, it's an excellent site and you can use it for a lot of different subject area currently in any of your subjects. So here's an example of when we say go to a whole new scenario. Here we've got an object that a lot of kids wouldn't know anything about. A lot of adults may not even know what that is either, but it comes apart, right? And now I can talk about a little bit of what do I see about the properties of this? It went back together again. What's it made of? Could it be made of other things? So this is for those of you who are around in school a little while ago, you remember conic sections. Well, there they are, parabolas and things. That's how we built them. Pick something that's their favorite. Okay, what is your favorite object that you have used for? What is it made of? What was the purpose of it? Like just again, linking it in for them to have that conversation with you and explain it using the scientific vocabulary that not just everyday kinds of language. So that's really what we're looking for too. So again, comparing the man-made, natural, maybe you have different objects or you got them to sort them out. They want to put them together. So that's another deeper level kind of question. It gets away from that surface level conversation. Choose an item that you want to create. What's its purpose? Let's do it the opposite. Figure out your purpose. What do you want to make? Now let's decide what materials would you need to use, right? So hold something, the amount, is it going to hold something? Is it going to move something? Whatever. What's the purpose of it? And then is the item only going to be made of natural materials? Can you find it? Can you go outside and walk and find it? What kind of material they're going to need, right? So just giving them the opportunity again to go at it from an open-ended resource side. Okay, let's go into resources very quickly. I don't want to spend a ton of time, but wherever we do find resources for you, we'll put them in here, including any small books that we can find. So in this case, I'm giving you this slide. It came from grade 1. And also from kindergarten. We used it in both because it's a great activity of just, I want to build vocabulary. I want them to tell me what they're feeling. I want them to use descriptive words, etc. So there's just some ideas on there that you can use and turn them into assessments if you wish. There's a book called What a Scientist Sees. So again, in grade 2, Ted's going to talk about that right away. Your scientific method. You are the rocks of the science world from grade 2 up. Everybody is going to learn how to do that in grade 2. And so grade 2s are the keeper of making sure that they get it right in the scientific method as they leave your door and head off into grade 3. And this is a nice little book which gives them some ideas. It uses the correct terminology. So again, it's one of those possible little resources that you might want to have. This is also one that we have shown both in math and in science. It fits in both. So remember I said, if you're going to sort in both. Don't just do it in one subject, do it in both together so they see the connections. This is one that also talks about, tell me about it. So what is the language they would use? What's the property of the object? What are they feeling using their senses language, etc. States of matter are things that we're going to unpack as we get into grade 3 when we name the states of matter. But I can say, you know, is this item something that I would eat? Is it something that's malleable? What can you do with spaghetti? Can it bend? Like all of those different pieces. I can look at it from that lens as well. So the nature of matter is one, it just talks a little bit more about matter around you. This is more of the grade 2. It talks a little bit about this in page 6, but the rest of it moves you into grade 3. And so it's not necessarily a book I would purchase just for grade 2. However, this one I would definitely buy. This is a good one. It's a book that covers a lot of material for you. So it's a nice little one. I got my copy at Scholastic. But again, I mean, you can get them in a lot of places. Now, having said that, I also want to point out to you that we don't know what kinds of resources might still be added to the new Learn Alberta site. So some of those resources might show up there, and then you'll have access to them. You'll see here that I've given you a link, Chemistry Made Simple, Properties of Matter. It's a slideshow, so here's the link for it. So it just gives you some additional resources that you might want to use and where it comes from. And then the ASC Chemistry for Life is another one that's a really popular one as far as kinds of materials that we need in our particular resources for science. So again, here's the link for you here that you have access to it just as a separate resource. Those books that I showed you about the igloo, about SAGE, about all of those come from the Grandmother Grandfather series. There is a teacher's book guide that goes with it, which provides you with additional resources, questions to ask students. So that's another one. And I just photocopied the back side of it here so that you can see it's nativereflections.com. So again, there's 2 sets of them. And this is set number 2, but if you have a look at the back of the book, which you can see when you look at it, you'll see which books are included in it. I have both, but you don't need both for grade 2, that's for sure. And today, oops, sorry. And here are some additional resources that we highlighted just so that we cite them. But I also want to just bring to your attention that Pearson has what's called a Spark library. And some of those little books that I show you come from there. I go in, I look to see what they have, and I just cite whatever the name of it is. So if you wish to go in and get a 30-day trial and just have a look at some books that are out there, there's one for you there. There's a link for you to go in and do that. All right, and then I think we'll get Ted to talk about our computing science and scientific methods. Well, actually, I can talk about this right now. Computing science, Ted will unpack that in just a moment, but we do have another member of the team, Ange Deering, who is one of the educational techs who works with the staff over at Wetaskiwin Regional Public Schools. And what she has done is gone in and created a short 12-minute video, including the slide deck, so you can use that as well, of how do I take computing science and teach that in grade 2 matter. So it's not about computers, it's not about robots and coding and things like that. It's more about asking good questions. So when you watch her video, she will tie it specifically into grade 2 matter. So you get some ideas of how you will integrate computing science into your grade 2 classroom. Okay.
So we can just go back one slide. Scientific methods and computer science are different organizing ideas compared to the other ones. These are more process-based organizing ideas, which in a sense means we're not going to teach it at the beginning of the year like we would matter or living systems, and then move on to the next organizing idea. As a process-based organizing idea, they've got skills in it that we'll want to move forward. The earlier skills graphic that I showed you with the list of skills, a lot of those from computer science and scientific methods are on there. So they're integrated and we could use those at any time and during any organizing idea. This graphic is just here to show you what's expected, not only grade 2, but the sort of the progression, so we can understand exactly what computer science is and what it's doing here. At the end of the day, in grade 3, students are going to be introduced to something called computational thinking, and it's different kind of thinking abilities. One of them is algorithmic thinking, which is making up rules or instructions of something, a sequence of things. And so really kindergarten, grade 1 and 2 really focuses on that algorithmic thinking part of it. They don't use that term here, and we don't use it, you don't see it anywhere here, but that's what it's leading to you can sort of see the end game. These different components are highlighted in different colors. The pink demonstrates all those, or highlights all those skills and procedure statements that are related to creating instructions. So in kindergarten, they create a two-step sequence of instructions for a given purpose. By grade 2, we're looking at 3 to 4-step sequence of instructions. And you can see where the connection is when we do eventually get to coding. It's all about putting instructions and making sure that the purpose, intended purpose at the end is completed. The yellow highlighted things are just following instructions, getting students to follow instructions. And that's something that, again, probably continues on to grade 2 and grade 3 and so on. The blue highlighted items are just what they have in common is they stop and think and reflect on the instructions for some reason. For example, in kindergarten, it's reflecting on it to discuss or recognize when the actions don't respond to the instructions. In grade 2, we start talking about predicting what the outcome is based on these instructions, or if things aren't working out, then perhaps how can we debug that and so on. So that's what the blue things are. So it's not really, as Chris mentioned, work with computers. It's really working about instructions, and we can use instructions at a variety of levels. You might have a grid, for example, and say, move this creature this way to get from the this living thing to this food or something like that, or what are the steps and procedures in creating an object, right? We're doing objects in matter. Maybe what's a simple thing they create, and what are the instructions, and can other kids replicate that? So that's how we can integrate things like that. Scientific method, same thing. There's some videos coming. There'll be access to you that give you better ideas than I just gave, but just to help you along. As Chris mentioned, grade 2 is kind of an important scientific methods organizing idea for all the grades up from grade 2, because they list in the center there those steps in the procedure for an investigation, which is asking questions, making predictions, planning the investigation, and observing and recording data as you go through your experiment or your test, whatever it is, then analyzing and reaching a conclusion, and then discussing the observations. Those things are those are words that kids are going to be using at grade 2 and up: conclusion, analyze, predict, and so on. So there'll be some more help available to you in the scientific methods components, and that's done by Nicole Lamoureux, where you can get a good sense of what it is and how to introduce it and how to integrate it into the steps. So that's really the key part of scientific methods for grade 2 at this level. And those videos, they're available on the ARPD site as well, which I posted already. There was a question up there earlier, Chris.
Okay. So let's go to the chat box and just quickly answer some questions before I stop recording. And then I'll open it up for anybody who wants to ask if you don't want to be recorded. So can you please clarify what words like described, including such as, or words in brackets in the knowledge indicators? So whenever you come across words in brackets in your curriculums, whether it's math, science, it doesn't matter, language arts, they're all interpreted the same way, that in theory, the word that is in the bracket is considered to be the most proper term for whatever it is you're teaching. In this case, it would be a scientific term. But they may feel that that word is too difficult for the students. So you might want to use the explanation or the word that's provided in front of the brackets to make it a little bit easier for the students. Now, that being said, there are many teachers who have said, I would still show them the words. I would still use the word. I may not necessarily, though, assess that word, and I might not use it every day all the time. And that's fair. So if you feel that your students can handle that word, then by all means, go ahead and use it. Just use it at your discretion and recognize that there has been a suggestion that an easier word might be there for them to use. Where will we get the updates? Karine, what updates are you referring to? The updates as in the missing slide decks, or can you just unmute yourself and let us know what you're asking?
Chris, sure. I think we're still recording. Sorry.
Oh, yeah, sorry. Okay, I'm just going to let her to answer it because chat box will show up in the recording. So I want people to know.
Yes, actually, Ted was just talking about some updates that are coming, some more information that's going to be added. And what I wanted to know was, will you add to this slide deck, or will we look for something separate?
They will actually be put either into that folder directly. So if let's say it's grade 2 matter, we'll either have it sitting right in there, or what we'll actually do for scientific method, we just had a meeting today, is we're going to put a little button above it. It'll just say grade 2 scientific method, and you can click it on and it will be available to you. So they will be not always updated directly in the slide deck right off the bat, but they will definitely be either in the folder with it or right in front of it.
Brilliant. This is so rich. Thank you so much.
You are most welcome. Okay, I'm just going to stop our recording here so then people will feel a little more comfortable.